So it kind of looks like that. And so basically, I'll read this. This is the image that you see in your textbook for example number 2, and they give us some dimensions here. And it says, while designing a house, an architect uses windows like the one shown here. What are the dimensions of the windows if you have to use 276 square inches, or inches squared, of glass? We need to, so basically to make this window, we have to solve, well, we're going to solve for x, but we're given the area of the window, okay? So now what is that? Well, the window is this right here. It's this rectangular shape, and then we're going to assume that that's a half a circle. So let's start with the circle first. What is the area for a circle? Pi r squared, right? So I'm going to say pi r squared. And what is the area for a rectangle? Length times width. So I've got two areas, okay? Now this area, let's think in terms of the radius. The radius starts here and goes from here to here, or you could think of it as going from here to here. What is the length of that radius?
Half x.
Half of x. So if and I'm going to write these two, I'm going to write this over here. Oh shoot, I wanted to move them all over here, but put them together. So let's start with the circle first. So we know that the area of the circle, and let me write it in red so you can see it. Let's say that the area of the circle is pi times x divided by 2 in parentheses squared. So that would mean that my area is equal to x squared over 4 times pi, right? Does that make sense? Now let's do the rectangle. The rectangle, let's just say that this is the length and x is the width. So the area of the rectangle is going to be length times width, or 2x times x, or a equals 2x squared. Okay, cool. So here's why we are going to use this for our example on quadratics and completing the square. I have two terms raised to the x. They have to equal this 26 or 2766, right? So now I'm going to do the math on this, and I'll probably run out of room, but we'll try this. So the two areas, the total area is equal to x squared plus, or x squared over 4 times pi, right, plus 2x squared. Well, what was the total area? 2766 inches squared, right? Now I'm going to clean this up a little bit. If I factored out an x squared, I would have x squared times the quantity, pi over 4 plus 2. And I'm going to pause there and let you guys look at that and see if that's correct. Does that seem right to you when I factored out the x squared? All right, so I'm using my old calculator because you guys, some of you guys have old calculators, so it was already on my screen too. So let's do the math on that. Let's get a decimal approximation, okay? So if I say second pi divided by 4 plus 2, I get 2.7853. Now I can leave it that way, or I can change it. But you know what I just realized? And I saw a hand go up, and maybe this is what you were trying to let me know. Hey, what is this? What is this an area of? A circle. What do we have?
A half a circle.
I have a circle. So I got to take this whole thing and multiply it by 1/2. So I got to put a 1/2 here and a 1/2 here, and then I got to tack on a 1/2 here. So how does that change all of this? Well, this has to become 8, right? Because 1/2 times 1/4 is 1/8. So that means that this has to become 1/8. Phew. Is that why you had your hand up? All right. So I'm glad I double checked that. I checked my notes and I was like, uh-oh, forgot something. So let's start over and we'll say second pi divided by 8 plus 2. So that'll change it a little bit. So it's 2.39. Okay. Now, this is an interesting thing. I can solve this the same way I solved the other one by just simply dividing both sides by pi over 8 plus 2. Okay? In other words, what I can do is I can say 2766 divided by, and then in parentheses put second pi divided by 8 plus 2. And enter. Okay? Now I get 1156 point something something something, right? So I'm going to get all of this stuff reduces down to 1156.016 repeating, and that equals x squared. But what am I solving for? X. So what do I got to do? I got to take the square root of both sides. So now what I'm going to do is I'm going to go back on my calculator and I'm going to say second and then choose the square root symbol. And now see how over the negative sign on your calculator in a different color it says ANS? If I hit second and that button, it will import the last answer that I had. So now that gives me about 34. Now it's plus or minus 34, right? But are we going to have a negative 34 for our measurement?
No.
No. So the fancy math word that Mr. Adams is going to start throwing out lately is, we call that an extraneous solution. In other words, what that means is it's a mathematical solution, but it's not applicable or practical for the application that we're using. Okay? So the answer then is about 34 inches. All right. So now the question that they asked us was, what are the dimensions of the window? We solve for x. Is 34 the dimensions of the window? No. We got to go back and plug that in. The dimensions of the window are 2 times x, or 2 times 34. Right? So that would be 68. And this obviously would be 34. But now what would my radius be? Half of that, which is what? 17. So this architect and the contractor, we'd have to communicate that information. The way that you make this window, you're going to make it a rectangular window that is 34 by, well, let's write it out. Rectangle window, 34 by 68. And then, I don't want to say half circle, we should say semicircle. Semicircle, semi by definition means half. Semicircle, radius of 17. And then the contractor will know how to construct this. And then, so then we would say total area, 2766 inches squared. Okay? Any questions on that one? Now we're yet to have actually completed the square. We're ramping up to it. But what we did these two problems at first because what it does is it shows us that we can isolate our equation in a certain way where we can take the square root of both sides and get an answer. Remember that a quadratic equation has 2 solutions. Even though we got an answer of 34, what were the 2 solutions in this case?
Positive, negative.
Plus and minus 34. Now, will they always be the same number?
No.
No, they're not always the same number. So in this case, it was. So let's do example number 3.